This is problem number 7 from section 3.3. In this problem, they say solve the equation x squared plus 2x plus 11 equals 0. Now, we have 4 ways to solve it. First way I always look at is the square roots way. I have an x squared term. Do I have any other terms with x in it? I do, and it's not an x squared term, so I can't combine them. That takes out the square root method. Can I factor this? Well, it's got a leading coefficient that's 1, so I might be able to, but the factors of 11 are 11 and 1, and there's no way I can add or subtract 11 and 1 and get 2. So factoring's out. That means for me, I'm probably going straight to the quadratic equation. I might here, it's possible I could do completing the square if I wanted to here. All right, just take this middle term, divide it by 2 and square it. But I feel like doing the quadratic equation. I think it's going to work just fine. So let's do the quadratic equation here. Pull out the quadratic formula. Start with b. We get negative, better write x equals, negative 2 plus and minus root 2 squared minus 4 times 1 times 11 all over, and that would be 2 times 1. So x equals negative 2. I'm going to plug all this in the calculator. So we're going to have 2 squared minus 4 times 1 times 11. Remember, I'm just putting it in there exactly how it's written. It gives me negative 40. So I get plus and minus root negative 40 over 2. Now I have to check to see, well, before I do that, let's go ahead and simplify this. This would equal negative 2 plus and minus. Because it's negative 40, I know there's a negative 1 in there. I can bring an I out, right? So I basically take care of the negative by writing I, root 40 over 2. Now I do have to check root 40. Can I simplify root 40? I know root 40 is root 4 times root 10. Well, I know root 10 is not a square, right? And the factors of 10 are 5 and 2. But root 4 is a perfect square. Root 4 is 2, right? So this is actually going to give you 2 root 10 there. So I'm going to rewrite this now as negative 2 plus and minus 2 root 10 over 2. And then I'm going to start to split this. So it says negative 2 over 2 plus and minus 2 root 10 over 2. I can simplify here, so I get negative 1 plus and minus. The 2's cancel, leaving you with root 10. And finally, I want to write that as x equals negative 1 plus root 10 or negative 1 minus root 10. And now I have the solutions for this problem. And they're written in standard form, which we like. Right? The real number is the negative 1. Complex number is the... and you know what I forgot this whole time? Crap. This would be 2i. 2i. Sometimes you'll do this. It's very easy to do. You just forget the I is there. You know what? I'll rewrite this a little better. Negative 1 plus I root 10 or negative 1 minus I root 10. Sometimes you'll do that. You'll forget the I is there. But it's important, especially because you know you're going to standard form. It's important that you recognize, okay, I got A plus BI form here. I got to make sure I have the I in there. Otherwise, that's not the imaginary part, right? So this is the real part, the negative ones, and these are the imaginary parts here.